Hello everyone, and welcome back to the second custom NPCs tutorial of my channel. Today we are going to learn how to create some basic scripts like these. A spawn point block with custom effects. An item that gives you a random PvP set with enchants. A gravitational ball. A lava pool potion. A teleport skill. And the bomb skill that uses the model created in the last tutorial. We will start the tutorial by clarifying that you need to know at least the basics of programming, such as what is a variable, a vector, a for loop, and so on. It is important that you also know the page where you can find all the information that we will use in this video. In this page, we will be able to look for the events and methods that can be used. The structure that follow the script works through events, i.e., in the world of Minecraft, to perform certain actions such as hitting a mob, eat, or die. Events occur, such as the died event. And within these events, we can write our code so that when that event occurs, also runs that code that we created. For example, when we hit or interact with an NPC, we could call some methods like pushing the NPC in a direction or also change its name or size. There are several places where we can write our scripts, such as NPCs, items, blocks, and players, and we are going to show examples of each one of them starting with the spawn point block. For this first example, we will explain a little more in-depth basic concepts, and in the following ones, we will only explain how it works. In this script, we will use two events. The init event that is executed every time that the script of the block is loaded or restarted, and the interact event that is executed every time that a player interacts with the block. The information related to the init event is stored inside a variable. We will call it E of event. Through this variable, we will be able to use the entities that are related to the event that has just happened. If we look for init in the web, a lot of options that can seem confusing will appear, but if we look closely, the one that interests us is the one related to a block, since we will use our script inside a block. When looking at the characteristics of the event, we can verify that when it is created, inside its constructor, it provides us an object of type iBlock, which is called block. This refers to the own block that we want to program, and from now on, we will refer to it as eBlock. This is the code we used for the block, which we will explain now. Within init event, we will use setModel to set the model of the block using the name of the block we want it to become and setScale for its size, which is 1 by default in Minecraft. Although it is necessary to clarify that if we change the size of the block, its hitbox will continue being that of a normal block. The important code is located within the interact event. If we look at the constructor of the interact event, we can see that it has a block, which is the block we referred to before, a player, which is the player who interacts with the block, and other information that we will not need for now. The first thing we will do is save the XYZ coordinates of the player's current spawn point and the coordinates of the block, in addition to the player's name. Next, we will compare whether the block's coordinates are the same as the player's spawn point. As you can see, A1 is added to the Y coordinate of the block. This is because the spawn point must be an air block. Therefore, the real spawn point is one block above the block with which we are interacting. Now there are two options. The first is that they are equal. This means that this block is already the spawn point. After this, a title will be shown that says that the spawn point is already this block. We will do this using eAPI. which allows us to execute commands. These commands require a world parameter that can easily be obtained using the method getWorld or typing .world after ePlayer. The first command is used to set the title times. The second is the text that we want to show in the form of a subtitle with its corresponding color. And the third is to specify that we only want text in the form of a subtitle, so we leave it empty. You can generate this type of text by going to a title generator website, which will generate the text that you have to enter. The second option is that the coordinates do not match. So first, we will set the block coordinates as the current spawn point, and we will call a new particle animation function. In this function, the block growth animation and particle spawning will be executed. We will call a thread, which will allow us to stop the code for a certain time. To make the animation, first, we will establish the height that we want the block to reach, and we start a for loop that will reach the height that we have determined and will increase slowly. Afterwards, we will spawn the particles with the spawn particle method. This method needs to specify the particle, the coordinates where the particles will spawn, which in this case is in the middle of the block, a variation in these coordinates, the speed of the particles, and the amount of them. After spawning the particles, we will increase the vertical size of the block with set scale, and we will wait 200 milliseconds, which is 0.2 seconds between each iteration. Basically, this is what the loop does. After that, we will stop the code again, and then a little particle explosion will occur on top of the block by increasing the speed of the particles. Finally, we will show a title in the same way as before, but changing the color and text. And that's everything about the spawn point block. The second script we are going to analyze is the random Armour Set. For this script, we will use a scripted item. To open the scripting interface, we will use Shift right-click. This is the complete script that we are going to explain. In this script, we will use the init and interact events again, but since it is an item instead of a block, these events are somewhat different. When looking at the constructor of the init event, we can see that it returns an object of type item scripted called item. This is the item that we are going to configure, and we will refer to it as e-item. Inside the init event, we will configure some things. The first one will be the name of the item through the method set custom name, which requires a string that is the name that we want to put me. Also, the texture of the item, which requires two parameters, the damage of the item, and a string with the name of the texture that we want to put to him. It is necessary to emphasize that all the scripted items that have the same damage will share the same skin. To change the actual texture of the item, call setItemDamage afterwards with the same damage value. I don't know why that is, but it's needed. With the setColor method, we can make a mix between the color that we choose and the color of the texture that already has. The value of the color must be in hexadecimal format. To get it, we can use several web pages to obtain the color that we want with its hexadecimal code. Using the setDurabilityShow method, we can configure if we want to show the life bar of the item. In this case, we don't want it to be seen. We can also set if the object can be staked, using setMaxStackSize. If we don't want it to be staked, we simply set the maximum to 1. And the description of the item, we add it with the method setLore, accompanied of a string that will be the description of the same one. In the event interact will be executed, what we want to happen when we interact with the item, which in this case will be to change what we have on for a set of armor that we and a sword, all enchanted with one of the enchantments that we have previously defined. To achieve this, first, we must understand that to add an item to the inventory of a player, we must know the full name of the item. For example, the gold boots are called in Minecraft at golden boots. The iron boots are called Minecraft to ironed boots, and so on. So the name is the same, but changing only the name of the item. We can then create a vector in which we keep the different types of armor that exist, such as diamond, gold, iron, or simply the ones we want to add, and choose a random position of this vector, for example, Minecraft diamond, to then add the part we want it to be of this type, as a helmet, getting so a string called Minecraft diamond helmet, which is what we need. We will also choose the enchantments we want to add to the armor and the sword. We have to define them in separate vectors, since most armor enchantments cannot be added to swords and vice versa. This is what the first lines of the code do: create the vectors to store the names and types that we want to use. Then, we will create the vectors in which we will store the results of the types of armor and their enchantments, to later, with a for loop, fill them. We will also create a vector to select the level of the enchantment that will be applied to the objects. The sword only requires one enchantment, so we will replace the last position of the enchantment vector with a sword enchantment. We are going to see an example of what we would have at this point of the script. We will already have 3 vectors with 5 positions. In the first one, we will have the type of armor. In the second one, the enchantment associated to that armor, and the last one, the level of enchantment. The order in which we assign the vectors does not matter. It only matters the position that corresponds to the sword, which in this case is the last one. Now we will create the full names that are necessary to create the items by simply adding the values we have chosen before to each part of the armor. And finally, we will create any variable with which we will create the different items using the create item method, which needs a string with the name of the object we are going to create, a damage for that object, and the number of objects of that type that we want to create. This method also requires the world in which the game is being played to be used. Once the object has been created, we will now add the enchantment we have chosen to take, using the add enchantment method, which requires the name of the enchantment and the strength of the enchantment, where we will use the vectors we have created before. Finally, we will use the set armor method to put in the player's inventory the armor in each slot. The set armor method needs a number, which is the armor slot, and the item that we are going to put in it. After creating and adding all the parts of the armor, we only need to create the sword and add an enchantment. But as there is no chainmail sword type, if this combination is given, it will be replaced by a wooden sword. Then we follow the normal process, but this time we will use the method setMainHandItem, that what it does is to put this item in the main hand, eliminating the item that we already had, if there was any. And that's all about the random armor item. The next script we are going to explain is the Gravitational Ball. The concept of what this script does is get the direction where the player is facing, spawn a snowball in front of it, push the snowball in that direction, and apply an effect to the entities near the snowball where it breaks. This script is also a scripted item and has different configuration options, such as the distance at which the snowball we throw appears, which should be at least 1.5 blocks away to avoid colliding with us. The speed at which the ball is thrown, the range of blocks on which the snowball will have an effect, and the time and strength of the effect. As you can see, you can change the effect, in this case, levitation, for any other existing effect in Minecraft. We will use the init and interact events. The first one will be to initialize the item and give an appearance to the object, as we did in the previous script, while the interact event will actually take care of all the operation of the item. Before starting the explanation of the code, I need to clarify that we are used to using 3 coordinates to describe points in 3 dimensions. But there are also other methods, such as spherical coordinates, where only two angles are needed, the vertical and horizontal, and a distance, to calculate a point in 3 dimensions. In this case, what we want to do is to push the snowball a certain distance in the same direction, in which that direction we can obtain it with the get pitch and get rotation methods. These methods return the vertical and horizontal angle in which the player is looking, and they are the angles that we see in the spherical coordinates. But to push the snowball, we only have the methods set motion x, set motion y, and set motion z that are in Cartesian coordinates. Therefore, we must do is to convert the information that gives us the player in spherical coordinates to Cartesian coordinates to be able to push the ball in that direction. The fifth thing we need to do is calculate the point where the snowball will spawn, which needs to be in front of the player. We will start creating a thread that allows us to stop the code, and then we will save the horizontal and vertical angle the player is facing at the moment he interacts with the object. These methods return the angle in degrees, so we must convert them to radians to work more comfortably with them. It should be noted that the vertical angle in Minecraft is inverted, therefore, we will invert the sign. Using the formulas for converting from spherical to Cartesian coordinates, we calculate the XYZ components of the point where the snowball will spawn. But as I said, we also need a distance. This distance is the start point variable that contains the initial distance where the snowball should appear. Next, we will create a variable with which we will create the snowball entity through the create entity method, which needs the name of the entity we want to create. Then we will establish the position of the entity snowball in the world with the XYZ components that we have calculated previously, and finally, we will spawn it. After that, we calculate the components of the endpoint where the snowball should go, using the same process we did before, but changing the distance, which in this case is inside the variable push, to finally push the snowball with the set motion methods. After pushing the snowball, we will wait until the snowball breaks or dies, using a while loop, and the method is alive. Inside the while loop, we will wait a little bit each time we check if the snowball is still alive, so as not to generate too much lag. Finally, if there are enemies near the place where the snowball has broken, we will store them in a vector called enemies, with the method getNearbyEntities, which needs the position where the entities will be searched, distance range to search, and the type of entity to be searched. Type 5 is for entities that are alive. To all the entities that are in the range of distance that we have established previously, the levitation effect will be added in this case using a for loop to go through all the positions of the vector enemies and the method add potion effect that needs the ID of the effect, the time of effect, the force, and a Boolean variable that determines if the particles of the effect will be seen or not. And this is how the gravitational snowball works. The fourth script we are going to explain is the lava pool potion. It is the first script that is going to be placed inside a player's script. This script is very similar to the previous script. Almost all the structure is the same except the end. It takes the direction where the player looks, generates a potion in front of him, pushes the potion in that direction, and now, instead of applying an effect to the nearby entities, we will create a lava pool with a specific shape. Looking more closely at the code, everything is practically the same, except that the variable that identifies the entity we create is now called pot. When arriving at the while loop, once the potion breaks, what we will do is to define the positions x and z of the lava blocks that we will create, taking as center the center of the figure that we want to make. In this case, we want to create the following shape with lava blocks. So, following the figure from top to bottom and from left to right, these are the coordinates of each block. So as you can see, the coordinates of the first block are the values of the first position of the x and z vectors, and the same with the second block and the rest of them. The only thing left to do is to replace the blocks that were in those positions by lava blocks. starting by obtaining the block using the getBlock method, which requires the X, Y, and Z coordinates of the block in that world. These will be obtained by adding the position of the lava potion and the coordinates we have stored in the vectors, and then using the setBlock method that requires a name of a block to set the lava blocks. But this script has a problem. It will always be triggered when the player interacts with something, regardless of what he does or has in his hand. We can fix this by adding a condition at the beginning of the script, in which the script will only run if the player has a specific object in his hand. For example, an object called Lava Potion Dispenser. This will be done by making use of the getMainHandItem method, which returns the object that the player has in hand. Then using the getDisplayName method, we will get the name of the object, so we can compare it with our string. And as you can see, the lava potion is only thrown when we have that item in our main hand. The next script we are going to focus on is the teleportation ability. In this script, pressing a specific key will generate a flow of particles that will move towards the direction in which we are looking, stopping either when we find a block or when we reach the maximum teleportation distance. What the codes does exactly is take the player's coordinates and the direction he is facing, spawn a straight line of particles in that direction, and check if his path is blocked or if the maximum distance has been reached. If any of these things happen, the player will be teleported to that position. The script will start making use of the key-pressed event. This event is triggered every time we press a key on our keyboard, and the mouse keys are also included. You can find the listo-f values of each key in the website. If we look more closely at the constructor of the event, we can see that there are variables like the player, the key that we have pressed, and different booleans that tell us if, at the moment of pressing the key, we were also pressing Control, Shift, Alt, or Meta. After that, the script will check if the pressed key is the one that we want. We create a thread and then define the variables of the particle type, the teleport distance, the start distance, and the particle travel speed. Next, we will save the player's coordinates, but adding 1.6 blocks in height, which is approximately the position of the player's head. We also save the direction in which the player is facing, as we have done before. Then, we start a for loop that will start from the initial distance, up to the maximum distance, increasing in each iteration the speed we set. In each iteration, we will do what we have seen in the previous scripts. We will calculate the coordinates of points in the direction in which the player is looking. The only difference is that now we increase the distance in each iteration. Then we will use the method spawn particle seen previously, and in the section of the components X, Y, Z, we sum to each one the coordinate of the initial point and the point that we have calculated in that iteration. After that, we check if the block we are in is different from the air. If it is different, it means that it would have collided with a block, and therefore we place the current distance as the final distance to end the loop. After that, we wait 10 milliseconds between each iteration. If we do not collide at any time with anything, the loop will come to an end, and we will teleport to the last position we have calculated, adding 2 blocks of height to avoid bugs like being trapped in the block. And this is everything about the teleport skill. Finally, we have reached the last script that we will explain in this video. The bombs skill. This is the ability that you could see in the previous tutorial, which consists of an NPC summoning a series of bombs around him that when they come into contact with the ground, they will explode and disappear. Actually, this ability is composed of 2 NPCs. One is the one who summons the bombs, and the other is the bombs themselves. These are nothing more than an NPC with the model we created in the previous video. Therefore, as there are 2 different NPCs, there will also be two different scripts. The first one that we are going to explain is the script of the NPC that invokes the bombs. In this, we will define first the number of bombs that we want to invoke, the range around the NPC on which the bombs will appear, and the height with respect to the NPC on which they will appear. After this, in this case as an example, we will use the interact event to start the attack, but we can use it in other scripts as a boss attack, where it would make more sense. We define a thread that will help us to stop the code the time that we need, to later create a for loop whose number of iterations will be the number of bombs that we want to invoke. After this, we will save the coordinates of the NPC along with a random number that is generated within the range that we have specified previously. Then we spawn a cloud of particles in the position we have chosen with the spawn particles method, and finally we spawn the NPC bomb with the spawn clone method that needs the coordinates where we want to spawn the clone, the tab where the clone is saved, and the name of the clone. Then we will wait 0.3 seconds for the process to repeat again. And this is how the first NPC works. Now it's time to explain the bomb NPC. The simple explanation for this script is that, first, we spawn the NPC at a certain height, then wait 0.5 seconds for the NPC to gain some vertical speed, and then wait until this vertical speed is 0, which means that the NPC has touched the ground and will explode. We will use the init event, which will activate as soon as the NPC has been spawned. Then, as always, we create a thread to be able to stop the code. After this, we will wait half a second. We wait this half a second for the NPC to gain some vertical speed as it starts to fall. This is because we will now check what is the vertical velocity of NPC. And if this is less than 0.1, it will mean that NPC has collided with the ground or some structure, so we'll spawn some particulates with the spawn particle method and make it explode through the explode method, which needs the coordinates where the explosion is going to be generated, the range of effect of the explosion, if we want it to produce fire and if we want it to break the blocks around it. In our case, we just want it to break the blocks. And finally, the NPC will despawn. And this is all about the ability to summon bombs. We have reached the end of this second tutorial on script programming. If you have learned something about scripting today and want to see more tutorials, leave a like and subscribe, as this videos take me a lot of time. Thank you so much for watching the video and see you soon.